In this video, we are going to continue our discussion on assembly-based welds inside of Autodesk Inventor. Here I have the Assembly Welds 2 IAM from our working files directory. In order to start the weldment environment here, we can do it in a very similar manner we did the fillet weld. We just choose the welds option from our process panel on our weld tab at the top of the screen, or we double click on the weld node inside of the tree. As you can see, I already have a few fillet welds in here, and I have existing preparations on this design as well. And we're going to begin our continued discussion here by looking at the groove weld option. So I'll choose groove from the weld panel, or you can right click and choose the groove weld option. Inside of this dialog box, we're presented with face selections and fill direction selection options. We have to specify which faces we would like to interact with this groove weld, and the groove weld command is a rather generic term for a lot of different types of welds you can create if you're familiar with welding procedures. So here we just have primarily groove to satisfy a lot of different types of welds, and it's based on what type of faces we select inside of our assembly. So the first face I'm going to select will be the face that was created by my preparation of a chamfer on this guard plate. So I will select that face there. Now to continue on to face selection 2, I could right click and choose continue. And here I'll choose this curvature here on top of the base plate. You will notice I'm not seeing any preview yet because I haven't satisfied the fill direction. And before I even get over to that particular step, I want to talk about the full face weld options. What these essentially mean is if I create this weld, does the weldment material exist across the entire face? Well, for my first face, I do want that to be a full face weld. For my second face, I do not want that to be a full face weld, because that will create weldment material that will extend beyond the guard plate onto this portion of the base plate. Now, depending on your selections, you might also get an option to chain tangent faces together. You can see that is currently grayed out. So I'm ready to choose my fill direction. Now your fill direction is basically a vector that you specify for it to help guide the groove weld for how it should generate the material. For instance, if I choose the fill direction option and then click this linear edge, you can see how that creates a weldment material that kind of spans over and fills back onto that part of the plate that I don't want. So perhaps that wasn't the best fill direction selection. What I'll do is go back to that and select something else. Well, maybe I can select a normal vector of this axis. And that looks a little bit better. So you can see it's not carrying over onto that part of the face I don't want. However, I did choose something that is probably not the best thing to have. I chose another part and the axis of that part. When you can, you should always try to choose origin features because they don't change. So my fill direction here, I'm going to specify to be the Z-axis under my origin folder, because that Z-axis won't change, and it gives me the same result. However, if I had lost this cylindrical component, then my groove weld would actually fail because it has no more fill direction reference. You can also create a welding symbol here. You will notice that there is no weld link available for this because it is not a fillet weld, but that doesn't stop us from being able to fill this in with different contour information or different tail notes or flag notes, whatever you'd like to have for your welding symbol. For here, I'll leave that unchecked and choose OK. And you can see the groove weld being created. Now, if I rotate this, you'll also notice that I don't need to have the end fill option either, like I had to do with my fillet welds up here. The next groove weld will be on these sleeves on the bottom side of the base plate. So I'll choose groove weld. Again, choose this face here as my first selection. That will be a full face weld. Face selection 2 will be the cylindrical face here. And then my fill direction, let's try the Z-axis. You can see that doesn't give me a valid result. So I'll choose something else. Let's choose the X-axis. You can see that gives me a partial fill on that. Now we do have another option here called a radial fill, and that will actually go all the way around. Now this ignore internal loops is a condition where you run into that you have to fill a groove weld that covers over a gap or a void in material, such as a hole or an area where you just want to have it backfill into something. So the ignore internal loops on a face is a little bit more rare. We don't really have a scenario here that dictates it. but know that that exists as well. I'll go ahead and apply that one, and I'll quickly perform a similar groove weld over here. Full face weld on selection 1, selection 2, and radial fill. I'll apply that. Notice how it's keeping my selections there during the apply process. Now, what if they don't touch at all? For instance, I have the sleeve here that's going through the base, but it doesn't touch in any direction anywhere around it. Well, you could do a groove weld here as well with that radial fill option. My first face selection to be a full face weld will be the inner face of the base plate. Face set 2 will be the cylindrical face, and you can see the radial fill takes place for me. I'll go ahead and apply that, and then cancel. Now, if you wanted to add a fillet weld over top of that, like you see over here on the left, just to make it cleaner, more real life of what you might see on the actual piece, you can absolutely do that. Now, the next one we're going to look at here is the cosmetic weld. A cosmetic weld is essentially something that will add the representation of a weld, but won't actually put the weldment material on there. I see this utilized a lot more when an engineer doesn't really understand what it will take to weld these parts together. They just want to tell the shop, hey, I want you to weld this for me. I don't know exactly what it's going to look like, and I don't want to insult you by putting something on there. Or maybe I don't want to show it in my visual documentation, but I do need to represent that that's welded together. So this will basically change the color of your edge, and it will say that there's a weld there. You can specify the area that will then add into your material properties, but it doesn't really actually add solid geometry like we've seen with the fillet weld and the groove weld command. So you can choose your selection method by edge, chain, or loop. You can still have your create welding symbol option there if you want to specify some tail note information for it. For now, I'm just going to say that I don't really know what goes on here between this groove weld and what you're going to have to put on top of this to secure that to the base plate better. So I'm just going to put a cosmetic weld on there and adjust the total area here. Right now it's in inches squared, but you can easily change that to another unit if you need to. So I'm going to say roughly we're going to add, based on my calculations, another 5 millimeters squared of material. I'll choose OK. You can see a visual cosmetic weld on that piece, but not actually really adding material. Now, if you need to modify groove welds or cosmetic welds, you'll find in your tree on the left-hand side, under the beads folder, your fillet weld beads, your groove weld beads, and your cosmetic beads. Lastly, if you have a lot of welding beads inside of your assembly, let's say this is a very large frame or something that just has welds everywhere, you could go up to your bead report at the top of the screen, choose all your subassemblies, and then you could export that to an Excel file, which is the next step here in this dialog, and that will allow you to get a complete bead report of your welds. For now, I'll choose Cancel to stop that command. And this concludes our look at the assembly welds inside of the weldment environment for Autodesk Inventor.